Hi, I'm Michael Woods. I'm at an orchard in southern Thailand right now, and these plants are growing really well in a soil with about 5% organic matter. Turfgrass grows well in soils with a substantial amount of organic matter too. However, the playability of a turfgrass surface can be too soft if organic matter accumulates right at the surface. That's why I find it so useful to measure the organic matter over time, the total organic matter as it accumulates. Let's go into the office now and we will have a look. I'll explain to you how I report these data in charts and how you can understand an OM246 report. The first thing that I want to look at, and I think that this one is the most important, is the total organic matter over time. This is especially useful to look at the organic matter as it changes over time at these three different depths. All right, let's have a look at some of these reports. What I start with on the very top, the very first thing I show is the organic matter over time. Now this report's in Japanese because it's for Kea Golf Club, but I will show you how this looks if I show it in English. So these are those same data for Kea Golf Club. This one I show at the very top of the report. It's what I think is the most important, and this is the total organic matter over time. So what we're looking at here is organic matter time series at three different depths. We're looking at it at a 0 to 2 centimeter depth, which is like the top 1 inch. Then we're looking at it at a 2 to 4 centimeter depth, and we're also looking at it at a 4 to 6 centimeter depth. And then it's showing this over time. In this case, for Kea Golf Club, it's from 2017 up until 2021, with all of those samples done in the springtime. And there's a horizontal dashed line across here that shows the average for that particular species of grass. So in this case, it's for zoysia grass, for Kori zoysia. That is the fine bladed type of zoysia like you can find on golf course putting greens. And this might seem like a substantial amount of organic matter, but the playability is just fine. And it's been really interesting to track this because there tends to be quite a bit of change right at the surface in the top 1 inch. So, or in this case, let's be specific and say in the top 2 centimeters. The organic matter has changed anywhere from 11.2% all the way up to 14.9%. So what's that? 3.7. It's changed by about 3.7% at that top 2 centimeter depth. And that's where the ball's reacting. That's where the mower's cutting the grass. That's where a lot of things are happening. That's where the ball mark is happening when the ball hits the green. If we go down just a little bit into the root zone, now notice that at the 2 to 4 centimeter depth, at the next layer down, over that same time period, it's only changed from 3.5%, then it dropped to a low of 3.3. It's been at a high of 4.2. So the range that has occurred, the range in organic matter, at the 2 to 4 centimeter depth has been 0.9% over that same 4-year period. And it's even less of a change as you get deeper down to the 4 to 6 centimeter depth. Now we're still less than 3 inches below the root zone, but now, we're less than 3 inches below the surface at the 4 to 6 centimeter depth. And that's changed. That went from 3.1, 3.1. Basically that was static. It didn't change from 2017 until 2020. And after a coring event last year, it dropped down now to 2.4. But we're still looking here at a difference or a range of only 0.7% in organic matter over a 4-year period. So when you look at this over time, you can see how the organic matter is changing. And you also, if you know what you've done for core aerification that removes organic matter, if you know what you've done with sand top dressing, which adds sand that presumably has very little organic matter in it. So if you're adding the sand, that has the effect of diluting the organic matter that's present in the root zone. So by looking at what you've done in terms of work, and then by measuring what the result has been over time, you can more precisely predict what you will need to do in the future to achieve the desired results. Let's zoom in now at just the 0 to 2 centimeter depth and look at what we have here. We have the 11.2% to start with. That is 112 grams of organic matter by mass per kilogram of total soil material. That's what 11.2% means in this case. And the next year in 2018, it was up to 12.3%, and then it was up to 14.4%. Now, this is the average across multiple greens on the property. And in 2017 to 2018, there was no core aerification. There were just 2 top dressing events. Again, from 2018 to 2019, there were just 2 top dressing events. In 2019 to 2020, there were also just 2 top dressing events. And last year, from spring of 2020 up until 2021, there was a single coring with 10 millimeter diameter tines, and there was an additional verticutting and sand top dressing event. So that's relatively minimal amounts of work. This is about 33% of the amount of sand top dressing that is typically recommended. And yet the organic matter numbers seem kind of high, but the playability is superb. If we go down to a deeper depth, now we're looking at the 4 to 6 centimeter depth of the same set of greens, and it just doesn't change nearly as much. So what was happening there, and this is why I question really whether we always need to be coring or even solid tining and putting sand down deeper into the root zone. We're talking here about a 4 to 6 centimeter depth. That is not very deep. And when we're going down to that depth, what you can see, 2017 to 2018, virtually no change. 2018 to 2019, also, there was no change on average in these greens at what the organic matter was at that depth. And remember, these greens were not getting cored. They were not getting solid tined. They were just getting a little bit of sand top dressing at the surface. And then from 2019 to 2020, again, very little change. It just stays constant, even though there was no sand going down there. So there is not a lot of accumulation of organic matter happening below the top inch, below the top 2 centimeters. And in fact, it went down, basically 3.1 to 2.4% is not a big change, but it seems like it because it seems like it on this chart because it had been flat for a few years. And what happened in 2020, there was a single coring event in which sand was applied to fill those holes. And so now you've got additional sand going down to that depth. And I presume that is the main reason why this number went down a little bit, because there would have been some additional sand going down to that depth. Now here's that type of chart for a different species. This is for a different golf course, and this is with creeping bentgrass. So you'll notice now the y-axis levels have changed, because now instead of being up around 12%, 13%, 14%, which is typical for mature zoysia greens, we're now we're now having numbers that are from 4.8% up to 6.9% at the 0 to 2 centimeter depth. And this is over a multi-year period. And you can see that the horizontal dashed line shows here the average for creeping bentgrass for the species of grass being shown here. Again, there's not a huge change when you get down to the 2 to 4 centimeter depth, and especially to the 4 to 6 centimeter depth. If you look at this, the change from 2020 up until 2021 over a 1 year period, the change has been 0.18%. That is not much of a change at all. So what you tend to see is appreciable changes right near the surface and very little changes down below. And I think if you do this type of testing at your facility, you may find that there is very little change, not a lot happening down below the surface. And to me, that brings into question why we need to punch holes and put sand down to a depth of 3 centimeters, 4 centimeters, 5 centimeters, 7 centimeters. We're talking now numbers that are like 2 or 3 inches below the surface. Why would we need to do that if it's a sand-based root zone? Typically, it's not going to have a compaction problem. So if we don't have a compaction problem, and if we don't have organic matter accumulating to excessive levels at those depths, then do we really need to be punching holes and putting sand down there? I think that's a question that we can all ask, and then these data can help us to answer it.
The next thing I like to look at is how your most recent samples at the 0 to 2 centimeter depth, the 2 to 4 centimeter depth, and the 4 to 6 centimeter depth, how those most recent results compare to other samples that have been measured from that exact same turfgrass species.
The second thing that I show on the report, the second type of chart that I show, and let's go back to the report and look at it. So the top row, the first thing that I show are these time series, and then I go down and show these curves. And let's look at what these curves are, what they mean. Now we're back to the cori greens, the zoysia greens. So this curve shows all the grasses of that, all the samples from grass of that species, from putting greens of that species. That's how the samples are distributed. So you have basically nothing below 5% at the 0 to 2 centimeter depth, and you would have very, very few samples above 25% organic matter at the 0 to 2 centimeter depth. If we look at the 2 to 4 centimeter depth, we could see now that we might have from about 1.5% up to about 8%. That's where we would typically find the samples to test at, and the bulk of them, the peak, the highest probability of a sample testing at a particular value would be somewhere around about 3%, up to 3.2% or so at the 2 to 4 centimeter depth. So the curve is showing basically the range that we would expect, and then the higher that peak, or wherever the peak is the highest, that shows you where most of the samples would be. And then this red point is showing the most recent data for the golf course that's been tested. So in this case, the most recent data for this golf course found that there was 12.7% organic matter in the top 0 to 2 centimeters. That was the average value. And if we compare that to all the other samples of zoysia, all the other cori greens, there were 42% of the samples would be higher than this value, and 58% would be below this value. What what this tells us is we're in the 58th percentile. And if we look at it at the 2 to 4 centimeter depth, the average is 3.8% for the most recent data, and this would put it in the 63rd percentile at that depth. So that's what that is showing. And if we zoom in on this, this is just at the 0 to 2 centimeter depth for those same core greens. So for zoysia greens, we would expect that the peak, the peak of that density curve is just above 10%. And as this curve gets lower and lower, there is less of a chance that you'd ever find a sample at testing at that particular value. The chance of getting a zoysia green that tests at 4% total organic matter in the top 2 centimeters is basically zero. You're just not going to find that unless it's on a brand new green. Also, it would be very unlikely to find one above 25%. That would also be very unlikely. And we can also look at this for bentgrass. So here's the bentgrass course that I was showing earlier. Now notice how these curves are totally different. Well, let's go back to that previous one. So here the curve starts at about 5% and it goes up to 25% because based on the data that's been collected so far, the zoysia greens are expected to fall within this range, with the highest probability is going to be right around 11% or so. That's if we'd never tested the golf course before, if we'd never tested that property before, and we just said, okay, you've got mature zoysia greens, let's go test it. What would we expect it to be? I'd say, well, probably it's going to be somewhere around 11% if I have to pick. Now for bentgrass, it's different. Instead of going from 5% to 25% with a peak around 11%, for bentgrass, it now goes from about 2.5% up to 12%, and the peak is right about 5%. Because for mature creeping bentgrass, you tend to have less organic matter than you have in zoysia greens. And for this particular golf course, the most recent samples were at 6.3% on average in the top 2 centimeters. That puts it in the 66th percentile because 66% of other bentgrass samples are testing below that value and 34% are testing above that value. And we can go then look, let's just jump over to the 4 to 6 centimeter depth. Now it's in the 13th percentile because the average value on the most recent test was only 0.8%. That's relatively low for a bentgrass green sample. And because that's relatively low for a bentgrass green sample, it is in the 13th percentile. 87% of bentgrass greens are expected to be above this. And in fact, this curve is going from about 0.4% up to a cutoff at about 3% because we just don't expect to see a lot of bentgrass green samples at the 4 to 6 centimeter depth testing above 3% in total organic matter. I think this chart is probably my favorite because it packs a lot of information and it shows some background information about what's normal for that species at different depths. But it's not as practically useful, I don't think, as the organic matter time series, because the time series is showing us what's happening year after year after year, and we can relate that to the maintenance work that's been done.
I also like to look at the total organic material by depth as a scatter plot. You can find your most recent samples identified on the chart, and in the background you'll see all the samples from every turfgrass species that have been measured so far in my database.
If we go to the next page of the report, this then shows a scatter plot. So I'll show you this in English now. if we look at this scatter plot in English, this is also for Kea Golf Club for the most recent samples. Now it's showing 3 different depths. So here is the depth, the 0 to 2 centimeter depth. The red points, these are the most recent values. This is the 15th green, the 3rd green, the 4th green, the 11th green, and the 9th green at Kea Golf Club. So now we can see that the range is from about 10 to 16% on these different greens on the property at that depth. And you see there's a bit of variability. All the other gray circles, those are all the other samples from other golf courses, from any kind of grass species, from ultra dwarf Bermuda grass, Poa annua, fine fescue, so many different types of grass. You see there's not a lot around 18 or 20%. There does tend to be a lot around 4 to 6 to 8% at that particular depth. And then we look down here, this shows from the 2 to 4 centimeter depth, and you'll notice that not only are all the values shifted lower, but also there's a lot less variability, where there is some variability here from the 15th green to the 9th green, and that shows up in how firm the surfaces are. It does show up in the playability on this particular golf course. As we get down to deeper depths, it is common to find much less variability, which is why you also notice there's only samples here from 3, 9, and 11 greens. Because there's more consistency at the deeper depths, I recommend doing more testing right near the surface and doing less testing down deeper in the root zone. Because if there's less variability deeper in the root zone, you don't really need to do extra tests, because you can do just a few tests and you're going to know what the levels are. And we can also look at the 4 to 6 centimeter depth. This also moves a little bit lower, and now it would be extremely rare to ever find a golf course putting green sample with organic matter at the 4 to 6 centimeter depth above 6%. That would be extremely uncommon. You can see both for Kea Golf Club and for all these other samples that have been tested from so many different grasses. It's almost everything. I think everything that I see is less than 6%. So this is a scatter plot that makes a nice summary, I think, of the most recent samples from different greens across the property, and it also shows the different depths, and it also shows some background information for other grass species at those different depths.
Another thing I like to look at is the change over time at the entire 0 to 6 centimeter or 0 to 2.4 inch depth. Now this is something where we can combine the data. We combine the 0 to 2 centimeter, combine the 2 to 4 centimeter, and combine the 4 to 6 centimeter depths, adjust for the bulk density, and now we can look at the total organic matter through that entire zone.
There's one more chart that I show on these reports, and that is looking at the total organic matter over time, not by depth now, but combining the depth. So looking at the 0 to 2 centimeter depth combined with 2 to 4 centimeter and 4 to 6 centimeter depth. I will show you how that looks. Here it's what I call the surface layer time series. So this is for Kea Golf Club. It's those notorious core eye greens that have 10, 12, 14, 16% organic matter right at the surface of the root zone at the 0 to 2 centimeter depth. But if we average that across the entire surface layer by combining the data from the 0 to 2 centimeter, 2 to 4, and 4 to 6 centimeter depths, we can see that we get a reasonable numbers. Now it's 5.3% starting off, and it just doesn't change too much. It goes 5.5, 5.6, 6.3. This most recent testing is down to 5.7. So in, what is this? 2017 to 2021, it's 4 years, 4 growing seasons. The total organic matter in the top 6 centimeters of the root zone has gone up by 0.4%. And this happened with 2 top dressings and 2 verticuttings, 2 top dressings and verticuttings, 2 top dressings and verticuttings. So that's 6 verticuts and 6 top dressings in the first 3 years. And last year, there was 1 coring and 1 verticut and top dress. So again, 2 top dressing events. Total, we're looking here at 8 top dressing events over 4 years, 1 coring event, and 7 verticuttings. And the organic matter didn't go up too much. So the growth there is pretty much under control because the greenkeeper, Andrew McDaniel, is not doing so much disruptive work. When he's not doing so much disruptive work, he doesn't have to put so much nitrogen fertilizer to stimulate growth because there's no damage that needs to be recovered from. And this may not work everywhere, but as I've said before, I think it probably has some application that it could work at more places than only this one golf course. And one of the reasons why we do the OM246 testing, the reason why I think that this is so incredibly useful is because we were quite worried that doing so little work, because honestly, 2 sand top dressings per year and no coring and no solid tining, that seems like not very much work. So we were concerned that not doing the typical maintenance of more frequent top dressing, of applying more sand than that amount, of doing some type of organic matter removal from by coring or solid tine aerification and putting sand down into the holes. We, and by we, I mean me and the head greenkeeper, Andrew McDaniel, we were worried that maybe the organic matter was accumulating too much below the surface, that it was accumulating and we weren't keeping track of it enough, and that perhaps it could come to cause some problems with playability, with the way that the grass could perform at some time in the future. So in 2015 and 2016, we started looking at some ways to measure this. And in 2017, we started doing this particular method that I call the OM246 testing. And we've been tracking it very closely over time. And it's fascinating to me to see how little change there is. There definitely is not a problem happening. And yet Andrew has been able to provide a playing surface that is in better condition for more days of the year because he's not doing so much verticutting. He's not spreading sand on the surface. He's not punching holes in the surface. He's not doing things that would disrupt the way a ball would roll across the surface. And it's not having negative impacts. And we're able to check for potential negative impacts by doing this OM246 testing. Now notice here that there's also a horizontal line that shows the average organic matter for this particular species. This is for cori. So the average here is a little bit above 5%. That's what would be typical in the top 0 to 6 centimeters. This is, by the way, this is 0 to 2.4 inches. And if we go down to another grass species, this is is creeping bentgrass. And the average for creeping bentgrass is about 3%. And this golf course is right at about that average. It was 3.1% in the spring of 2020, down to 2.6% in January of this year, and back up to 3.1%. And that was in July. So this number is different. It's lower than what you see on zoysia greens, but it's also not changing so much over time. And this is also interesting, perhaps if you're familiar with Dr. Caro's recommendation. His recommendation was in the top 2 inches that you should not exceed 4% organic matter. And this is a recommendation from research that he did about 20 years ago in the southeastern part of the United States. And it was focused primarily on creeping bentgrass greens, although he did a little bit also with ultra-dwarf Bermuda grass greens. And he found that when creeping bentgrass greens in the top 2 inches exceeded 4% organic matter, that could lead to problems, especially in the hot weather of summer that's typical in that part of the world. With the OM246 testing, you are able to also get that value and make calculations. In this case, I'm showing from a 0 to 6 centimeter depth, but we can also make that calculation from a 0 to 5.1 centimeter depth, which would be 2 inches. So that is the surface layer time series, which is interesting to look at, although you don't see as much change here as you would see right at the surface in the top 0 to 2 centimeters. So these are the reports. This is English report would show these same charts. So I start off by showing the time series at 3 different depths. And that to me is the most important. And then I think it's interesting to look at the comparison to different species. So we do that with these density charts. And then moving on to the next page, we look at a scatter plot, and then we look at the total organic matter over time. And we do that not just for the different depths, but we combine the depths and look at it like that.
I hope you found this look at these charts and the OM246 reports useful. And you can find plenty more information about this and other turfgrass topics, as always, at asianturfgrass.com. Thank you.